Alrighty guys, let's go ahead and get started with our parallel examples. First thing we need to do is draw a parallel circuit, and we should remember that a parallel circuit is a circuit that has more than one path. So we're just going to say that a parallel circuit has multiple paths, and we'll see what that looks like in just a sec. So here's my battery down here, one side bigger than the other. Here's my wire, and then here's my first resistor here. So that's one path. And then I do the same thing. I add to it. Now I have two paths and two resistors. Then I do it again. Now I have three paths and three resistors. How do I know that each of these resistors is in parallel? Well, we can just do the test that if we shut off or one of these resistors stops working, it should not impact the other resistor and the other one should still stay on. And let's see if that's the case really quick. So here's my energy moving around my circuit, moving around. And let's say it goes to this resistor over here. Well, if I shut this one off, that doesn't affect this path at all. It can still continue through that path. Now let's try again, but this time let's go to the far resistor. So we go up, it's still not impacted, can go all the way around and come back again. All right. So that means that none of these resistors are going to impact each other, meaning that they are all in parallel. Awesome. All right, number two, if the parallel resistors are as follows, 10, 20, 40, and 60, what is the total resistance? So something important to note is that in parallel, our equation looks something like this, the total resistance, and I like to write it like this, saying RT is equal to R1 to the negative first plus R2 to the negative first plus R3 to the negative first plus R4 to the negative first, and all of this to the negative first. This is the same way as just writing this, saying 1 over our total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3, so on and so forth. I guarantee if you plug the purple equation into your calculator, you will get it right a lot more times than you will the red one. The red one messes up some people because they forget that for this equation, you're just solving for 1 over RT, so you still have to flip everything at the end. With the purple, everything's solved for you. So if I do this and I plug this in my calculator, I should end up with 5.26 ohms. Number three, based on our square of love, what is the same throughout the circuit? So for a parallel circuit, the thing that's the same is going to be our voltage. And that just means that each resistor, since it has its own path, is going to get its maximum amount of energy that that battery is supplying. So think about you have like a table, right? And there's food on the table. Each person has their own plate. They can go up and get the full amount of food that fits on that plate because everybody has their own plate for it. So let's look at number four. A parallel circuit is connected to a 30-volt battery and contains two different resistors. The first resistor is 10 ohms and the second resistor is 15 ohms. Complete the square of love and draw a picture. So here's our picture. Here's our battery. Here's our first resistor over here. There's our first path. And then here is our second resistor over here, second path. So if I label it, my battery is 30 volts. My first resistor is 10 ohms. My second resistor is 15 ohms. So I'm going to go ahead and write 15 here. Next, I'm going to go ahead and start filling out my chart. So it told me that the total voltage, or the voltage of my battery, is 30. So I'll fill in 30 here. R1, the resistance, is 10. And R2, the resistance, is 15. So because this is a parallel circuit, it has various rules. And we talked about one of them above, and that was the fact that voltage is the same everywhere. So our total voltage is equal to the first voltage, which equals the second voltage, which equals the third, so on and so forth. So all of these voltages should be 30. Now that we have that out of the way, we can start solving for current and then resistance. We know voltage is equal to current times resistance. So if I solve for my first current through resistor 1, I get 30 equals I times 10. I solve for I by dividing by 10, and I find out that the current through my first resistor should be 3 amps. I do the same thing for my second resistor. 30 equals, this time R is 15. Divide both sides by 15, and I find out that the current through my second resistor is 2. Now I need another rule to figure out what the total current is through my circuit. And I know that total current for a parallel circuit is equal to each of the currents added up together. So we're going to add all those currents up to get our total. Therefore, 2 plus 3 equals 5. That's my total current. Lastly, my total resistance. I could go back and I could use that really difficult equation up here that we had before, or I could take the cheap way out and just use Ohm's law. Ohm's law tells me that voltage is equal to current times resistance. So my voltage is 30, my current is 5, my resistance is unknown. I find out that 30 divided by 5 is equal to my resistance, which is just 6. A property of parallel circuits is that our total resistance is always going to be the smallest resistance in the circuit. Now let's take a look at number 5. A parallel circuit contains two different resistors. The voltage across resistor 1 is 150 volts. I'll write V1 here. The current through resistor 2 is 0.75 amps. So I will try to write I2 here, saying that this is the current through resistor 2. And the total current of the circuit is 2.25 amps. And I'll just write IT here. So if I go ahead and I draw my circuit, again, this is just your basic parallel circuit. So I could draw it something like this, just like I did above, where I have these two resistors and my battery. Or I could also draw it like this, where I have my battery over here. I have one resistor on this side, and then I do my other loop over here, and I have one resistor over here. There's two different paths, so this is still a parallel circuit. So if I want to start filling out my box down below, I know that the voltage through resistor 1 is 150, so I can put that here. The current through resistor 2 is 0.75, and my total current is 2.25. So we're missing a lot of information here, but we should be able to figure this out. All we have to do is look at our rules above. We said total voltage remains the same everywhere. So 150 volts through R1 means 150 volts through R2. Means 150 total volts through the circuit. Now that I have that, it's starting to open up. I know V is equal to I times R. So if I want to solve for R over here, I set 150 equal to my current, which is 0.75, times my resistance. That's going to tell me that R2 is going to be equal to 200 ohms. Next, I can either solve for R total over here, or I can solve for current and then R1 and then R total. It doesn't matter. Let's solve for R total really quick. So this time we have 150 volts as well, except our current is 2.25 and R is unknown. Divide 2.25 over to the other side, and we find out that our total resistance for this circuit should be 66.67. Lastly, let's go ahead and solve for current. I know that the total current is equal to the currents being added together. So if I plug those currents into my equation, I get 2.25 is equal to 0.75 plus my unknown current. All I have to do is subtract 0.75 over to the other side, and I find out that the current through resistor 1 should be 1.5. Lastly, I solve for my resistance of R1. So I have 150 is equal to 1.5 times R. Divide 1.5 over to the other side, and I end up with a resistance that is equal to 100 ohms. All right, let's take a look at number 6 right now. Complete a square love for the parallel circuit with 4 resistors. Wow. The first resistor has a voltage of 20 volts. So I'll write that right here. And it has a resistance of 15 ohms. The second resistor is 6 ohms, and the third resistor is 8 ohms. The total current is 11.6, and now we need to complete this square love and figure out what is going on. So first things first, V equals I times R. That's going to help us figure out what the current is right here. So 20 is equal to I times R, which is 15. Divide 15 by both sides, and I find out that my first current should be about 1.33. Next, because this is a parallel circuit, voltage is the same everywhere, so all of these voltages are going to be 20. Now I can solve for total resistance over here. I know that voltage is equal to current times resistance, So voltage equals my current, which is 11.6, times my resistance. Divide each side by 11.6, solve for resistance, and I find out that the resistance should be 1.72. Next, I can just go ahead and start solving for the currents over here. And again, we use Ohm's law to do that. So voltage is equal to current times resistance. 20 equals 6 times I. Divide both sides by 6. I find out that the current should be equal to 3.33. And then I also find out that resistor 3 has a voltage of 20, and the current is unknown, and the resistance is 8. So therefore, the current for resistance 3 should be 2.5. Lastly, I'm just missing these boxes down here. This should be easy. So in a parallel circuit, the total current is equal to all the currents added up together. So if I do that, I should be able to take my equation right here and plug in my values. I find out that my total current is 11.6. Current of resistor 1 is 1.33. Current of resistor 2 is 3.33. Current of resistor 3 is 2.5. And the other current is unknown. Add all these up, subtract it over, and I find out that my resistance 4 has a current of 4.44. Next, I solve for my last variable here, which is my fourth resistor. Voltage equals current times resistance, 4.44, times R, divide by 4.44, and I find out that my resistor should be 4.5. How do I know that my current's right here? Well, if I add all these up, it equals 11.6. How do I know my resistance is correct here? If I use my resistance equation, which told me that RT is equal to R1 to the negative first plus R2 to the negative first plus R3 to the negative first plus R4 to the negative first, all to the negative first, I end up with 1.72. And I recommend that if you guys are unsure or just to double check that you go and do these steps. So I would try the total resistance and I would make sure that all my currents add up as well.